KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, now we are discussing three-dimensional geometry, miscellaneous exercise problems. Okay. Next question, question number 14. If the points 1, 1P and -3, 0, 1 be equidistant from the plane r bar dot 3i cap plus 4j cap minus 12k cap plus 13 equal to 0, find the value of P. Now here given that two points are equidistant from a plane, we have to find the value of P. Two points are equidistant from the plane means distance from a point to plane and distance from another point to plane, these are equal. Simply calculate the distance from one point to plane, consider it as d1, and calculate distance from other point to the plane, consider it as d2. What is given? d1 equal to d2. That's it. Okay. What is given here? The points 1, 1P and -3, 0, 1 be equidistant from the plane r bar dot 3i cap plus 4j cap minus 12k cap plus 13 equal to 0. Okay, but this plane equation is given in vector form. I'll write corresponding Cartesian form. Okay, given equation of plane is r bar dot 3i cap plus 4j cap minus 12k cap plus 13 equal to 0. Okay, now r bar be the position vector of any point P, any point xyz, then r bar is equal to xi cap plus yj cap plus zk cap. So in place of r bar, if you write xi cap plus yj cap plus zk cap, what we get? Dot product of these two gives 3x plus 4y minus 12z plus 13 equal to 0 is the Cartesian form of this plane equation. Okay, and this is vector form given, corresponding Cartesian form is 3x plus 4y minus 12z plus 13 equal to 0. Now it is r bar dot n bar equal to d form. Okay, this is ax plus by plus cz is equal to d form. Okay, now what is given? Distance of these 2 points 1, 1P -3, 0, 1 are equal from the plane. Okay, so distance of point 1, 1P from the plane. Okay, now what we know? Distance of a point x1, y1, z1 from the plane ax plus by plus cz plus d equal to 0 is modulus of ax1 plus by1 plus cz1 plus d upon square root of a square plus b square plus c square. So using that formula, the distance of the point 1, 1P from the plane is d1 is equal to magnitude of, in place of x, y, z, write 1, 1P. So 3 into 1 plus 4 into 1 minus 12 into P plus 13 upon square root of a square plus b square plus c square, 3 square plus 4 square plus minus 12 square. Minus 12 square is nothing but 12 square. So numerator is how much? 3 plus 4, 7 plus 13, 20 minus 12P. Okay, numerator is magnitude of 20 minus 12P upon denominator 144 plus 16 plus 9. Okay, 144 plus 25 is 169. Square root of 169 is 13. Square root of 169 is 13. So denominator is 13. Okay. So d1 is equal to how much we got? Modulus of 20 minus 12P upon 13. Okay. Now distance from the point -3, 0, 1 to the plane I will consider as d2. Okay, the distance of the point minus 3, 0, 1 from the plane is d2 is equal to, in place of here in the plane equation, in place of x, y, z, substitute minus 3, 0, 1. So 3 into minus 3 plus 4 into 0 minus 12 into 1 plus 13 upon square root of 3 square plus 4 square plus 12 square. So denominator is 3 ma. Numerator how much here? Minus 9, this is 0, minus 12 plus 13. Okay, minus 12 plus 13 is how much? 1. 1 minus 9 is what? 1 minus 9 is minus 8. So modulus of minus 8 is what? 8. 8 by 13. Okay, so d1 what we got? Modulus of 20 minus 12p by 13, and d2 what we got? 8 by 13. Okay, what is given? d1 is equal to d2 given d1 is equal to d2. Now d1 is equal to d2 means modulus of 20 minus 12p by 13 is equal to 8 by 13. Both sides 13 cancel. So what we have? Modulus of 20 minus 12p is equal to 8. Whenever mod x is equal to a, what is it meaning is x is equal to either a or minus a. Okay, so modulus of 20 minus 12p is equal to 8. What is it meaning is 20 minus 12p is equal to 8 or 20 minus 12p is equal to minus 8. Okay, plus or minus 8. So 20 minus 12p is equal to 8. If you consider 20 minus 12p is equal to 8, so what we have? 12p is equal to 12, p is equal to 1. Okay, if 20 minus 12p is equal to minus 8, okay, 20 minus 12p is equal to minus 8, 12p is equal to 28, okay, p is equal to 28 by 12, 4 cancelling numerator and denominator, p value is 7 by 3. Okay, so what are the values of p? Either p is equal to 1 or p is equal to 7 by 3. P is equal to 1 or p is equal to 7 by 3. Okay, now what we did here? Simply find distance from a point to plane. Okay, distance from 1p to the plane consider as d1, and distance from minus 3, 0, 1 to the plane consider as d2. Okay, consider d1 equal to d2. Okay, get p value as 1 or 7 by 3. Okay, my next question number 15. Question number 15. Find the equation of plane passing through line of intersection of planes r bar dot I cap plus j cap plus k cap is equal to 1 and r bar dot 2I cap plus 3j cap minus k cap plus 4 equal to 0 and parallel to x axis. What is given here? Find equation of plane passing through line of intersection of two planes. Already we discussed family of planes passing through line of intersection of two planes r bar dot n1 bar equal to d1 and r bar dot n2 bar equal to d2 is given as r bar dot product with n1 plus n1 bar plus lambda n2 bar is equal to d1 plus lambda d2. Equation of plane passing through line of intersection of two planes r bar dot n1 bar equal to d1 and r bar dot n2 bar equal to d2 is r bar dot n1 bar plus lambda n2 bar equal to d1 plus lambda d2. So what are the given planes? First one, equation of plane passing through intersection of planes r bar dot I cap plus j cap plus k cap is equal to 1. So r bar dot n1 bar equal to d1. So in place of n1 bar what we have? I cap plus j cap plus k cap. In place of d1 what we have? 1. Okay. Second plane equation r bar dot product with 2I cap plus 3j cap minus k cap is equal to minus 4. Okay. Now here n2 bar is what? N2 bar is 2I cap plus 3j cap minus k cap equal to d2. d2 is what? Minus 4. So family of planes passing through intersection of two planes r bar dot n1 bar plus equal to d1 and r bar dot n2 bar equal to d2 is r bar dot n1 bar plus lambda times of n2 bar is equal to d1 plus lambda d2. Okay, so r bar dot n1 bar, what is n1 bar? I cap plus j cap plus k cap plus lambda times of n2 bar. N2 bar is what? 2I cap plus 3j cap minus k cap is equal to d1 1 plus lambda d2. Lambda times of d2 is what? Minus 4. So 1 minus 4 lambda. Now this plane will simplify like this, r bar dot product with, here I cap, here 2 lambda I cap. So I cap plus 2 lambda I cap, what we can write, 1 plus 2 lambda I cap plus j cap plus 3 lambda j cap, that we can write as 1 plus 3 lambda j cap plus k cap minus lambda k cap, what we can write, 1 minus lambda k cap is equal to 1 minus 4 lambda. Okay, now this plane equation, first equation, r bar dot n bar is equal to d form. Okay, so normal to this plane is what? Normal to this plane is 1 plus 2 lambda I cap plus 1 plus 3 lambda j cap plus 1 minus lambda k cap. So nothing but direction ratios of normal to this plane, direction ratios of normal to this plane are 1 plus 2 lambda, 1 plus 3 lambda and 1 minus lambda. Direction ratios of normal to this plane are 1 plus 2 lambda, 1 plus 3 lambda, 1 minus lambda. Okay, now once go back to the question. What is the question, ma? Find the equation of plane passing through line of intersection of these two planes and parallel to x-axis. Plane is parallel to x-axis. As plane is parallel to x-axis, normal to the plane is perpendicular to x-axis. As plane is parallel to x-axis, normal to the plane is perpendicular to x-axis. As plane is parallel to x-axis, normal to the plane is perpendicular to x-axis. Okay, so the direction ratios of x-axis, what are the direction ratios of x-axis? 1 0 0 1 0 0 are direction ratios of x-axis. Now x-axis and this normal are perpendicular to each other. Okay, so two lines are perpendicular to each other, then a1 a2 plus b1 b2 plus c1 c2 equal to 0. Okay, so what we have here, 1 0 0, here 1 plus 2 lambda, 1 plus 3 lambda, 1 minus lambda. Now what we can write, 1 into 1 plus 2 lambda plus 0 into 1 plus 3 lambda plus 0 into 1 minus lambda equal to 0. So 1 plus 2 lambda equal to 0. So 2 lambda is equal to minus 1, lambda is equal to minus 1 by 2. Lambda is equal to minus 1 by 2. Lambda is equal to minus 1 by 2. Okay. Now as lambda value is minus 1 by 2, substitute lambda value minus 1 by 2 in equation 1. Substitute lambda value minus 1 by 2 in equation 1. So from equation 1, what we can write, r bar dot product with 1 plus 2 lambda, 1 plus 2 into lambda value minus 1 by 2, 2 cancel, 1 minus 1 is 0 I cap. So I quotient is 0 plus 1 plus 3 lambda, 1 plus 3 lambda is what, minus 3 by 2, so 1 minus 3 by 2, 1 minus 3 by 2 is what, minus 1 by 2, so minus 1 by 2 j cap plus 1 minus lambda k cap, 1 minus minus 1 by 2, minus of minus plus 1 by 2, 1 plus 1 by 2 is 3 by 2, 3 by 2 k cap. So r bar dot minus 1 by 2 j cap plus 3 by 2 k cap is equal to, right hand side what we have, 1 minus 4 lambda. So 1 minus 4 into lambda value minus 1 by 2, minus of minus plus 2 cancel, 1 plus 2 3. Okay, so what we have, equation of plane is, required equation of plane is r bar dot product with minus 1 by 2 j cap plus 3 by 2 k cap is equal to 3. My equation of plane is r bar dot product with minus 1 by 2 j cap plus 3 by 2 k cap is equal to 3. Okay. Now further we can simplify like this, but taking LCM as 2. Okay. Now what we get, r bar dot product with j cap minus 3k cap is equal to, both sides multiply with 2 ma. Okay. Now this side will get as 6. Now write 6 this side. So what we get, r bar dot product with j cap minus 3k cap plus 6 equal to 0. Nothing but multiply with minus 2 on both sides here. Multiply with minus 2. Okay. You will get the final equation as r bar dot product with j cap minus 3k cap plus 6 is equal to 0. Okay. This is the required vector equation of the plane. This is the required vector equation of the plane. Okay. Next question. Question number 17. Find the equation of plane. Find the equation of plane which contains the line of intersection of planes Find equation of plane which contains line of intersection of planes r bar dot product with I cap plus 2j cap plus 3k cap minus 4 equal to 0, and r bar dot product with 2I cap plus j cap minus k cap plus 5 equal to 0, and which is perpendicular to the plane r bar dot product with 5I cap plus 3j cap minus 6k cap plus 8 equal to 0. First of all, equation of plane containing the line of intersection of two planes r bar dot n1 bar equal to d1 and r bar dot n2 bar equal to d2 is r bar dot product with n1 bar plus lambda n2 bar is equal to d1 plus lambda d2. Okay, so equation of plane passing through line of intersection of planes r bar dot product with I cap plus 2j cap plus 3k cap is equal to 4, and r bar dot 2I cap plus j cap minus 2I cap plus j cap minus k cap plus 5 equal to 0 is, this one you consider as n1 bar, d1 is 4, this one 2I cap plus j cap minus k cap as n2 bar, and d2 is minus 5. Okay, so equation of plane passing through line of intersection of two planes is r bar dot n1 bar plus lambda n2 bar is equal to d1 plus lambda d2. So r bar dot n1 bar I cap plus 2j cap plus 3k cap plus lambda times of n2 bar is 2I cap plus j cap minus k cap is equal to d1 plus lambda d2. d1 is 4 plus lambda d2 is what, minus 5. So minus 5 lambda, 4 minus 5 lambda. Okay, now if we simplify this plane equation, what we can write, r bar dot product with here I cap, here 2 lambda I cap, so 1 plus 2 lambda I cap. Okay, now 2j cap plus lambda j cap, nothing but 2 plus lambda j cap plus 3k cap minus lambda k cap, nothing but 3 minus lambda k cap is equal to 4 minus 5 lambda. Okay, I'll mark this one as 1. Now this is of the form, equation 1 is of the form r bar dot n bar is equal to d. So n bar is 1 plus 2 lambda I cap plus 2 plus lambda j cap plus 3 minus lambda k cap. So direction ratios of normal are what? 1 plus 2 lambda, 2 plus lambda and 3 minus lambda. Okay, what is given in the question? Required plane is perpendicular to the plane r bar dot product with 5I cap plus 3j cap minus 6k cap plus 8 equal to 0. Okay, required plane is perpendicular to this plane. Okay, now direction ratios of this plane are what? Direction ratios of normal to this plane are 5, 3, minus 6. 5, 3, minus 6. Now as these two are perpendicular, equation 1 and this plane are perpendicular, okay, then a1 a2 plus b1 b2 plus c1 c2 equal to 0. Here a1 b1 c1 are 1 plus 2 lambda, 2 plus lambda, 3 minus lambda. a2 b2 c2 are 5, 3 and minus 6. So a1 a2 5 into 1 plus 2 lambda plus b1 b2 3 into 2 plus lambda plus c1 c2, okay, 3 minus lambda into minus 6 is equal to 0. Okay, to simplify, 5 plus 10 lambda, 6 plus 3 lambda minus 18 plus 3 lambda is equal to 0. So after simplification, what we got? 19 lambda minus 7 equal to 0, nothing but lambda value is 7 upon 19. Lambda value is 7 upon 19. Now substitute this lambda value 7 upon 19 in equation 1. We get the required equation of plane. Okay, so from 1 r bar dot product with 1 plus 2 lambda. 1 plus 2 lambda is what? 14 by 19. So 1 plus 14 by 19 I cap plus 2 lambda j cap, 2 plus lambda 7 by 19 j cap plus 3 minus lambda, 3 minus 7 by 19 k cap is equal to 4 minus 5 lambda. 5 lambda is 35 by 19. Okay, so here after simplification, what we have? R bar dot product with 33 by 19 I cap plus 45 by 19 j cap plus 50 by 19 k cap is equal to right hand side 41 by 19. Okay, take LCM 19, cancel 19 on both sides, we will get vector equation of plane as r bar dot product with 33 I cap plus 45 j cap plus 50 k cap is equal to 41. Okay, this is the vector equation of the plane. Now corresponding Cartesian equation of the plane, how we can write? in place of r bar write xi cap plus yj cap plus zk cap. So what we get, 33x plus 45y plus 50z is equal to 41. Okay, 33x plus 45y plus 50z is equal to 41. This is the Cartesian equation of the plane. This is the Cartesian equation of the plane. Okay, next question. If O is origin and the coordinates of P are 1, 2, minus 3. Okay, O is origin and coordinates of point P are 1, 2, minus 3. Then find the equation of plane passing through P. Equation of plane passing through P and perpendicular to OP. Okay, but to find out equation of plane, what we need a point on the plane and direction ratios of its normal. So here point on the plane is given as P 1, 2, minus 3. Okay, 1, 2, minus 3. So what we can write, equation of plane passing through a point x1, y1, z1 is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0, where a, b, c are direction ratios of normal. A, B, C are direction ratios of normal. Okay, what is given here? Equation of passing through P and perpendicular to OP. So normal to this plane is what? OP. Okay, so when you know x1, y1, z1 and x2, y2, z2 are 2 points on a line, okay, then its direction ratios are x2 minus x1, y2 minus y1, z2 minus z1. So direction ratios of OP, what we get? O means origin 0, 0, 0, P is 1, 2, minus 3. So direction ratios of OP, what we get? 1 minus 0, 2 minus 0, minus 3, minus 0, nothing but 1, 2, minus 3. Okay, direction ratios of OP are 1, 2, minus 3. Okay, so this is nothing but direction ratios of normal also, no? Okay, and the direction ratios of normal to the plane are 1, 2, minus 3. So ABC values are 1, 2, minus 3 and x1, y1, z1 are 1, 2, minus 3. So required equation of plane is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Okay, a value 1, b value 2, c value minus 3. And x1, y1, z1 is also 1, 2, minus 3. So applying here, a into x minus x1, 1 into x minus 1 plus b into y minus y1, 2 into y minus 2 plus c into z minus z1 minus 3 into z minus of minus plus 3 equal to 0. So nothing but what we get, x plus 2y minus 3z is equal to 1 plus 4 plus 9, okay, 14. Okay, minus 1 minus 4 minus 9, nothing but minus 14. So x plus 2y minus 3z minus 14 equal to 0. This is the required equation of the plane. Okay, this is the required equation of the plane. Okay, ma, I'll conclude up to here, ma. We'll continue remaining problems in next session. Thank you.